Hello and welcome to 4-4, trig functions of any angle. Let's say that I have a point, x comma y, that is a point on the terminal side of theta, meaning it on the final side of the angle. And r is equal to the square root of x squared plus y squared, and it does not equal 0. I have some trig functions that exist. Now, these are similar to what we had in 4-2 with the unit circle. The reason why these are similar is because in the unit circle we were always dealing with a radius of 1. But now what I'm saying is I'm going to have any point on a standard coordinate plane graph, and I want to find the sine, cosine, and the angle that is formed by the angle and that point. In other words, a straight line drawn from the origin to that point. What is that angle? What is the sine, cosine, and tangent, cosecant, secant, and cotangent of that angle? Well, the r will be the length from the origin to that point. Now, if this looks like Pythagorean theorem, that's because it is. Because what I've basically got here is I'm creating a right triangle with the horizontal axis, that being the x-axis, and I'm basically using my x comma y as the lengths of that triangle. So let's say I've got a point, -3, 4. I want to find the sine, cosine, and tangent of the angle. Well, I need to find the r, the radius, if you will, for that point. So it's going to be the square root of -3 squared plus 4 squared. So we're going to find our x. We have our x, we have our y. Now let's find our r. So 9 plus 16. So the r equals 5. So the sine of theta, is y over r. The cosine of theta, I should draw that as theta, not just not, but theta. The cosine of theta is x over r, and the tangent of theta is y over x. So that will be 4 over 5. The cosine will be -3 over 5, and the tangent will be 4 over -3. So once again, I had x and y, I find r, and then I just use the definitions to find those trig functions. So given that the tangent of theta is -5 over 4, and that the cosine of theta is greater than 0, find the sine of theta and the secant of theta. Well, the tangent of theta is -5 over 4. Remember, tangent is the same thing as slope. So the tangent of theta is going to be, that is my y comma x. I need to find r. So my r in this case is going to be the square root of 5 squared plus 4 squared. So my r will be the square root of 25 plus 16. Thus, r is the square root of 41. Now, what's key here is that they tell us that the cosine of theta is greater than 0. And this is why they tell us that. If I were to plot this, I could be at one of 2 points, because they don't tell us where the negative applies at. I could either be at 2, 3, -4, comma, +5, or I could be at positive 4, negative 5. So because the cosine of theta has to be greater than 0, this tells me that my x value is positive. That tells me that this is the correct point, which means x is going to be 4, and y is going to be negative 5, and r is going to be the square root of 41. Had they not told me that the cosine of theta was positive, had they just left that out of there, there would have been potentially two sets of answers based on where you position that point. Because all they give you, if all they give you is negative 5 over 4, really that negative could be applying to the 5 or the 4. But because they tell you the cosine is positive and cosine corresponds to x, then that means the x has to be positive. So now I'm going to find the sine. The sine of theta is y over r. So it'll be negative 5 over the square root of 41. And then I rationalize my denominator. Negative 5 times the square root of 41 over 41. The secant is the reciprocal of the cosine, so it'll be r over x. So the square root of 41 over 4. And that is my answer. I don't care about it being decimal. I like radicals. Okay? So evaluate the cosine and tangent functions for the 4 quadrant angles of 0, pi over 2, pi, and 3 pi over 2. Well, if I draw my unit circle, I know I have 1, 0, 0, 1, negative 1, 0, and 0, negative 1. I know that this is 0, pi over 2, pi, and 3 pi over 2. So evaluate the cosine and the tangent functions for the 4 quadrant angles. So the cosine of 0 is the x value at 0, which is 1. The tangent of 0 is y over x, which is 0 over 1. The cosine of pi over 2 is the x value at pi over 2, which is the number 0. The tangent at pi over 2 is y over x, which is 1 over 0, which is undefined. The cosine of pi will be negative 1, and the tangent of pi will be negative 1 over 0. Will be 0 over negative 1, which is 0. And finally, the cosine of 3 pi over 2 is the x-coordinate there, which is 0. And the tangent of 3 pi over 2 is y over x, which is negative 1 over 0, which is undefined. So you do not ever have a tangent of pi over 2 or 3 pi over 2. Why? Because it's slope and you have a straight line. And you can't do that. It's a straight line up and down that's undefined. Now, the definition of a reference angle. A reference angle is the acute angle that is formed by the terminal side of your angle and the horizontal axis. So I've given you 3 examples here. So if I were to draw this angle here, being theta, this angle is, the reference angle, is the one that basically forms a right triangle with the horizontal axis. Same thing here for quadrant 3. It is basically what is the small angle that creates a right triangle with the horizontal axis. The reason why this is important to you is that if you find your reference angle, it makes it easier to find, like on the unit circle, what you're doing and where you're doing it at. So find the reference angle for each of these angles. So for 300 degrees, that would be 300 degrees. So my theta prime, which is the reference angle, would be 60 degrees. If I were to get 2.3, well, I kind of have to ask myself, where does 2.3 fall? Because I don't have a pi there. Well, I remember that pi is 3.14. So if I want to find 3.14, that's 1 pi. Half of pi would be like 1.6 something. So I know that this one is going to end up being somewhere over here. Because this is pi, this is 0, this is pi over 2. So in terms of radian, all the way over 180 degrees is 3.14, or 1 pi. Well, this is going to be larger than that, so now what I'm going to do is I'm going to basically take 3.14 and subtract 2.3 from it to get 0.84, and that's my reference angle. So basically what I did is I figured out what quadrant it's in, and then I just subtract away what I need to subtract to find that little portion. Okay? In this case, the entire straight line is 180 degrees. I basically found this is theta prime, and it's 0.84 radians. Negative 135. Negative 135, well, that's negative 90, and then negative 135. So theta prime will be 180 minus 135, which is 45. So my reference angle there would be 45 degrees, and that being the angle that is formed by the terminal side of the original angle and the horizontal axis. To find the trig value of any angle theta, you can determine the value for the reference angle, and then depending on which quadrant theta lies in, you can affix the appropriate sign. By using reference angles and special angles discussed in the preceding section, you can greatly extend the scope of exact trig values. For example, knowing that the function values of 30 degrees means that you know the function values of all angles for which 30 degrees is a reference. The table below shows exact trig functions of special angles and quadrant values. Notice the undefined there. We've already talked about probably every single one of these, but here's just a quick table of them. So what you do is when you find the reference angle, Like in the last problem we dealt with where it was negative 135, and so we know that we basically had a negative 45 because it's over in quadrant 3. I can go down 45, and I've got sine, cosine, and tangent like that, and I'm good to go because I know which quadrant it lies in. So evaluate the trig function of each of these. Well, the cosine of 4 pi over 3, if I were to put that back in degrees so you can see what it looks like in degrees as well, 180 over pi is 240 degrees. If I were to graph 240 degrees, goes beyond 180, and it goes over to here, and it's somewhere over here. Well, the theta prime for this one, if I subtract it away, I basically get 60 degrees down here, because it's gone 180 degrees, and now the remaining that it goes is another 60 degrees. So now I just simply look back, all right, the cosine of 60 degrees, cosine is 1/2. And because of the quadrant that it's in, I know that it will be negative. Just like that. The tangent of negative 210 degrees. Graph it. Okay? Graph it. So this is negative 180, and then it goes another 30 degrees. Well, that reference angle, theta prime, is 30 degrees. I notice that because of its location, because I know tangent is x over y, that the x value here is going to be negative because I'm to the left of the origin. So now I go to my chart, and I look at 30 degrees. Tangent is square root of 3 over 3. Negative square root of 3 over 3. The cosecant of 11 pi over 4. Okay, it's always easiest to put it back into degrees until you really get the hang of radians. It's just a method that you can do. 45 times 11 is 495 degrees. Well, when I graph that, there's 360, so let's subtract 360 from it. So now I've got 135 degrees. So now I've still got to go another 135 degrees. There's 90, which means I go another 45 degrees. This reference angle will be 45 degrees. So theta prime is equal to 45 degrees. So once again, I had a number, I had an angle that was larger than 2 pi, larger than 360. So I go once around the whole thing, and then take that away and see what I'm left with. I'm left with 135 degrees. So now I'm going to go around 90, and then another 45, and then my reference angle, drawing that line straight down to make that right triangle with the horizontal axis, is 45 degrees. So now I know I have because of where my placement is, I will have, depending on what I deal with, maybe a negative number, maybe not. So I'm dealing with cosecant. Cosecant is a reciprocal of sine. So I have the sine of 45 is square root of 2 over 2. So if the sine of 45 is the square root of 2 over 2, and sine corresponds to y, and I'm above the x-axis, so I'm good for positive, negative, so the cosecant of 45 will be 2 over the square root of 2. You cannot leave a radical in the denominator, so rationalize to get 2 square root of 2 over 2. which will give me square root of 2. So the cosecant of 11 pi over 4 is equal to the square root of 2. So once again, draw out your angle, figure out how far you're going, then once you've drawn your line for the end of your angle, just drop a line straight down and figure out the angle that it's making with the x-axis. So let theta be an angle in quadrant 2 such that the sine of the angle is 1 over 3. Find the cosine and the tangent by using trig identities. So I know that I have some angle that is 1 over 3 is the sine of the angle. So I've got some angle that is 1 over 3. We're going to find the cosine and the tangent by using trig identities. Now, for this you would want to look at the beginning of your packet where I gave you your trig identities, and we would want to use our Pythagorean identity that says that the sine squared of theta plus the cosine squared of theta equals 1. So I'm going to have 1/3 squared plus cosine squared theta equals 1. So I'll get 1 over 9 plus the cosine squared theta equals 1. So I'm going to subtract 1/9 from both sides. So I'll get 9 over 9 minus 1 over 9. And I will have 8 over 9. So the cosine of theta, cosine squared of theta, is 8 over 9. Take the square root of both sides. The cosine squared of theta, will equal the square root of 8 over the square root of 9. Square root of 9 is 3. And the square root of 8 is, when we rationalize, or when we reduce it, it's 2 times the square root of 2. So that is the cosine of the angle. So now, I know that I've got an angle such that it's over here in the second quadrant, because this is quadrant 1, this is quadrant 2. So I've got an angle over here such that the sine of the angle is 1 over 3, and the cosine is square root of 2 times the square root of 2 over 3. What this will become particularly important is, because of the placement of the angle, I have to mark this as negative because the cosine corresponds to the x value. So now I'm going to have the tangent. So because of the quotient identity, the tangent of theta is equal to the sine of theta over the cosine of theta. So the tangent of theta will be 1 over 3 over 2 times the square root of 2 over 3. So what that gets me is 1 over 3 times 3 over 2 times the square root of 2. My 3's cancel. Tangent of theta is 1 over 2 times the square root of 2. Rationalize your denominator, and the tangent of theta, and remember I still have a negative, so the tangent of theta here will be square root of 2 over 2 times 2, which means square root of 2 over 4. using the trig identities, and that will be negative. And that makes sense that it would be negative because if it's in quadrant 2, that means it's in the upper left quadrant, and tangent is slope, so I would have negative square root of 2 over 4.